Hey students, welcome back.
This is Mrs. Brunk, and today we're going to be continuing our discussion of equations of parallel and perpendicular lines. And we had a review lesson that was called Part 1 of 4 or 5, where we went back and looked at Algebra 1 skills that we learned about writing equations for lines. And we reviewed these two important forms of equations for lines. One's called point-slope form and one's called slope-intercept form. Now our preferred format is slope-intercept form. And so that is our goal, is to get our equations in slope-intercept form. But point-slope form is a really handy format to use when we know a point and the slope of a line. So today we're going to shift the focus from just a single line to pairs of lines. And so we're going to try to answer the question, how can we write the equation of a line that is parallel or perpendicular to another line? Equations of lines that are parallel have the same slope. That's what we mean when we say slant. We mean same slope, right? But they have different y-intercepts. If they had the same slope and the same y-intercept, they would cross at exactly the same spot and have the same slant. They would be the same line. Okay, we call those coincident lines. They're not parallel. They're the exact same line. And parallel means they don't touch at all, like they never cross. But lines that are parallel have the same slope. And that's all that we know for sure, is the slope has to be the same, but then the y-intercept has to be a different number, okay? So like, for instance, if I had an equation like this, y equals 2x plus 5, which was one from the homework assignment yesterday, and I had another one that was y equals 2x minus 7, those both have the same slope, but different y-intercepts, right? So these would run with the same slant, but one would cross way up at 5, and one would cross way down on the y-axis at -7. Okay, so those would be parallel lines. We're asked in example 1 to write the slope-intercept form of the equation of the line described. So they want us to write it in this form, y equals mx plus b. And they say they want it to pass through the point 1, 2. In other words, we have a xy coordinate of one point. I'm going to call it x1 and y1, of 1, 2. So it crosses through that point, and it's parallel to 7x plus 5. And what that means is the slope of this line I'm trying to write, we know the slope is 5. So I actually know that m equals, I'm sorry, not 5, is 7, excuse me, 7. So we have everything we need now to use that point slope form, right? So that's y minus y1 equals m times x minus x sub 1. So again, we're going to use this formula right up here, and we're going to just plug in what we know, because we know the slope now, and we know a point, and we can put it in the form that we need by just distributing. So that would be y minus, well, the y coordinate up here is 2, equals 7 times x minus the x coordinate up here, which is 1. And then finally, we're just going to distribute and put our like terms together on the same side. So distribute the 7 through. That makes 7x minus 7, and y minus 2 equals that. So now I'm just going to add 2 to both sides, right? Add 2, and my final equation is y equals 7x plus, not plus, sorry, minus 5, because -7 plus 2 is -5. So there's an equation that has the same slope as this original one, right? But it has a different y-intercept. This one crosses at +5, and the new one I wrote crosses at -5. So any questions on that so far? We're going to do another example. So what we had to do is get from the equation that they gave us only the slope. That's all I really cared about, was to just, I looked at it, and this equation right here, the only thing I took from it was the 7, okay? Because I knew the slope was the same if the lines are parallel, okay? That's by definition. Lines that are parallel have the same slope. Okay, so we'll try one more together, and then I'm going to ask you guys to try one as a you try. So So through the point 4, 5. So the point, this is x1, this is y1. My slope is going to be the same as this line's slope, because again, they're parallel. So that's what I look for, is parallel, same slope. So I'm going to borrow that slope of 3/4 and I'm going to use it with this point. And I'm going to put that point slope form down. So let's see, y minus, well, the y coordinate is 5, equals the slope, which is 3/4, times x minus 4. And that actually is the equation. It's just not in the form I need. I need it in y equals mx plus b form, and that means I have to distribute and simplify it to get it in the right form. But otherwise, that technically is the correct equation. Okay? But to get it in the form I need to distribute the 3/4 through, which makes 3/4 x. And then 3/4 times minus 4 is minus 3. Okay. Last thing I'm going to do is add 5 to both sides. So I'm going to just add the 5 here and add the 5 over here. So that makes y equals 3/4 x plus 2, because minus 3 plus 5 is plus 2. So there's my new equation that's parallel to this one. This one has a slope of 3/4 crosses at -1, and the one that I wrote has a slope of 3/4 that crosses at 2 instead. So they will be running just the same 3/4 slope, right? But one will cross down at -1 and one will cross on the y-axis at +2. So let's see, C wants me to write an equation for a parallel line through the point -2, 0. So this is my ordered pair. This is an x1 and a y1, right? Just one just means, that subscript just means it's one of the points that they gave me. In fact, they only gave me one point here. And they want it to be parallel to the line y equals x minus 5. Well, that looks different than the ones we've looked at because there's nothing in front of the x. Well, there actually is. This really means y equals 1x minus 5. So this one actually has a slope of 1. So they just leave that off if the slope is 1. So I know that the slope of the line I'm going to write is going to be 1. So m is 1. And then this is my xy coordinate that I'm going to use in point slope form. So I just substitute in that y coordinate in here. So that's y minus 0 equals the slope, which is 1, times x minus the x coordinate of that point, which is -2. So simplify this side, it's 1 times x plus 2 equals y. Well, that's almost in y equals mx plus b form, right? The 1 slope doesn't really do anything, so I don't really have to distribute anything through. So really, it's just y equals x plus 2. So again, this has a slope of 1, just like this other line does. So our two lines are parallel because they have the same slope. Oops. But the y-intercepts are different. The original equation had a y-intercept of -5, and the new one had a y-intercept of 2. Now, honestly, I don't even pay attention to what the y-intercept of the original one is at first, because all I get from that equation is the slope. Sometimes I see students get caught up in like they take that -5 and try to put it into the formula for point slope somehow, but that has nothing to do with your line. Only the slope. Only that the value of the slope do we use to write our new equation. Okay, the y-intercept is obviously going to be different, so we don't really care about that. We just use the same slope. Okay, so we're at this point where we have to decide on a U-try question. So I think we're going to make E be our U-try question. There are two more, and you're welcome to give those a try if you need more practice, but we did quite a lot of equation writing yesterday, and we have some things to go. So we're going to make E be a U-try question, okay? And so give that one a try, and then submit your answers to me whenever I give you the information to do that. So, okay, so thank you for giving that a try. Your correct answer for E should have been y equals -2x plus 5, and I saw a lot of those in the chat. So. Bravo. And if you didn't get that, then make sure you go back and check back through your work again, and make sure that you see where that's coming from, where that positive 5 for the y-intercept is. Hopefully you see the slope comes from right here, that we've got a -2 slope. Now if you want to give the other two a try, I'm going to tell you what the answers are, so this gives you a chance you can try them and then compare to the correct answer. D, the final equation should have looked like this: y equals -8/3, x minus 4. And F would be y equals 4/5, x plus 4. So give those a try if you want to. Come back and look at the solutions and jot them down maybe over in the margins so that you can try them back later and gives you another chance to test yourself. Okay? So now we're going to move on and we're going to talk about perpendicular lines. Okay? Equations of lines that are perpendicular, instead of having the exact same slope, they actually have about as opposite a slope as you can have. Not only are they the opposite sign, but they're also reciprocal. So if you think about all the ways you can make numbers opposite, right? You can flip them and you can change the sign. And that's actually what we know about perpendicular lines, is they have the opposite and reciprocal slope. So for example, if I had an equation for a line that was like y equals 3/4 x plus 7, a line that would be perpendicular to it would be something like, say, y equals -4/3 x plus 2, something like that. Those are parallel lines because their slopes, I'm sorry, not parallel. Why did I just say parallel? Sorry, guys. That is not correct. Perpendicular, which is how we do the perpendicular symbol, they're perpendicular because their slopes are reciprocals and opposite sign. And another way to tell is if you were to calculate the product of those two slopes, in other words, actually multiply them, you should get always -1. So that's another way you'll see it defined as the product of perpendicular lines slopes is -1. I think functionally it's easier to think about just taking and changing the sign and flipping it. So that's what we do. So otherwise it's the same as dealing with parallel lines, except for that when we read the slope of the given line, then we have to take the opposite and flip it so that we get the slope of the line that would intersect it at 90 degrees instead of be going at the exact same slant, right? So here's an example. So I want you to write in slope-intercept form the equation of the line that goes through the point -5, -1. So again, this is my x sub 1 coordinate, and this is my y sub 1 coordinate, right? And that is perpendicular to the line y equals 5/2 x plus 2. Now in the last ones where we did the parallel, we just took the exact slope and we used it again. But here, we're going to take that 5/2, we're going to flip it, and we're going to change the sign. So the sign will be negative and the fraction will now be 2/5. So that's going to be our new slope. So we know our equation, we know the slope of it. Now we just got to figure out the y-intercept by putting it into point slope form. So point slope form, again, we know is y minus y1 equals m times x minus x1. Now the subscripts mean we're actually going to put specific values in there. The other x and the y are the ones that actually are in the equation as your variables. Y equals mx plus b, right? So now let's plug in what we know. We know the x coordinate is -5. That's going to go in here. We know the y coordinate is -1. That's going to go in here. And our new slope, m, is going to go right there. So let's see. Y minus -1 equals -2/5 times x minus -5. Well, I'm going to clean this all up and make these pluses now, right? Because these are supposed to, if you have two negatives, it turns into a plus. So that's really y plus 1, right, on this side. And here I'm going to go ahead and distribute -2/5 to x, which would be -2/5 x, and then -2/5 to +5 is actually going to be -2. So, because 5 times -2/5, the 5s would cancel and just leave you with -2. Okay, so last step is to subtract 1, right, because I've got to get this 1 to the other side, right? And my final equation then would be y equals -2/5 x minus 3. Okay, And that's going to be perpendicular to this line right here because they have opposite reciprocal slopes. Okay. Okay, let's take a look at the next problem. So this time we want to make a line that is perpendicular to a line with a equation y equals 5x plus 3 and goes to the point 5, negative 5. Well, so first of all, my slope has to be the opposite and reciprocal of 5. So if I have a whole number like that, I'm going to take and get the reciprocal by doing 1 over that number. So that would be 1/5. And then I have to change the sign, so it's opposite and reciprocal, so negative 1/5. My xy coordinate is going to be that 5, negative 5, so my x1 and my y1 are right here. So I'm going to take those and substitute into point slope. So that would be y minus, well, the y coordinate is negative 5. The slope is negative 1/5. And the x coordinate is 5. Once I get to this point, now I just have to distribute. I'm going to change my signs, fix these signs. This is going to be minus negative makes a plus, right? Distribute that negative 1/5 through, which would be negative 1/5 x, and then negative 1/5 times negative 5 is positive 1. This was y plus 5 over here, so now I'm going to subtract 5 to get the y all alone and get it in the form I need, and that makes negative 1/5 x minus 4. Okay. So yeah, we know now because these have opposite reciprocal slopes, they must be perpendicular to each other. So that's what we're looking at. We're looking at the slopes and we're comparing. If the lines are parallel, they have the same slope. If they're perpendicular, they're as opposite as they can be. They're the opposite sign and they're the reciprocal. So let's go ahead and try one more together, and then we'll designate one of these to do as a you try, and the other two I'll give you the answers for. So if you would like to try them after class, you can check your work. So let's see. Let's try. Well, let's go ahead with C. This will be our last one we do together. Actually, yeah, we'll go with 3. So the slope of my new line, so my new line is going to be perpendicular to a line that has a negative 1/2 slope. So if I take 1/2 and flip it, I get 2, and then change the sign, that's going to be positive 2, right? So the original was negative 1/2, the new is 2. If I were to take negative 1/2 and multiply it by 2, I would get negative 1, which is what I said. That's how you know if they're actually perpendicular, is if their slopes, the product of them is negative 1. So now all we have to do is plug into point slope form. So y minus, well, this is the y coordinate, right? Equals the new slope, which is 2, times x minus the x coordinate, which is this one. Distribute and simplify. So that's 2x minus 10 over here, y minus 3. I'm going to add 3 to get 3 on the other side. I can only put it with like terms, right? So that's y equals 2x minus 7. Because negative 10 plus 3 is negative 7. So there's my equation, and there's the original one. Those two are perpendicular. They have opposite reciprocal slopes. So here's our chance to test our knowledge. So I'm going to give you D as a you try question. Okay, I'm going to pause the video so you guys can give this a try. And then I'll also provide you with the answers to E and F at the end of the lesson so you can test yourself and try a couple more before you move on and do the assignment. The you try question, so the correct answer to the you try question was y is equal to negative 5x plus 5. So again, we had y minus 0. Okay, that's plugging in the coordinate, right? The slope of the new line would have to be negative 5. If we take 1/5 and flip it and change the sign, we get negative 5. Multiply that by x minus 1. When I distribute the negative 5 through, I get negative 5x, and then negative 5 times negative 1 is positive 5. And then since that was a y minus 0 on the other side, there's nothing to bring back over. So That's my final answer. Now, if you want to, we'll go ahead and end the lesson here. And if you want to try the last two, the answers, so you can check yourself, should be 4/3, y equals 4/3 x minus 4. And then on F should be y equals, negative 1/2 x plus 1. Okay, and again, if you compare those slopes there, you'll see why that has to be the case. The y-intercept you'll have to check, because that's just plugging in the point slope form. But if you look at these slopes, these are opposite reciprocals, and so we know at least those lines are perpendicular to the original line. Hopefully the y-intercept is correct too, and that's the specific line that holds the point 30 or negative 4,3. Okay, so that actually does it for class, and I'll see you soon. Actually, see you tomorrow.